Hi everyone, I'm Alex Ma. Today we're going to be talking about this topic. It's quite a mouthful, enabling high availability with multi-site rack-aware replication. And so there's a number of, I think, topics today that are covering, multi-data center, HA, DR in some way, shape, or form. And in this talk, we're really going to focus just kind of on how we do it within Couchbase itself, and some of the things to watch out for, what a given topology will look like, what you should do if you're trying to do this kind of setup. So I'm a principal solutions engineer at Couchbase. I've been here for about 3 years, and our team works in the field. And so it's kind of interesting. I get to work with a lot of customers before they go live in production, and I also get to work with a lot of customers once they're actually in production, sometimes living on site with them for a week or a month. So I get to see a lot of cool stuff. And let's see here. We'll take a look at these slides. So I wanted to start you off with some of the basics about how Couchbase works. I know there's varying levels of experience in this room, so we're just kind of gonna take it step by step. So in terms of the Couchbase basics, there's a couple things to know about. So we have nodes in a Couchbase cluster. Whatever kind of data set that we're going to have is going to get evenly distributed across all of the nodes in a given cluster. Let's see here. So each machine in the cluster is going to store both active and replica copies of the data set. And it's not quite a master-slave where there's dedicated slaves in the environment itself. You can think of it more like, in this example, we've got an active shard. I can't actually see the number of it. I think it's 5. Active shard 5 living on server 1. Its replica lives on server 3. And so all of the replicas for server 1 are going to live on the remaining servers in the cluster. Okay? So the replication will get distributed out in a fairly even way. In Couchbase, it's a consistent system. So we only go to the actives for the data set for any kind of request. And that's really mainly because we don't need to do reads off of replica or reads off of slave to scale read IO. So in a lot of different systems, like on MySQL, you'll have slaves, you'll have multiple slaves where you'll be servicing reads from them. And those reads may be slightly dirty because it's got to copy off the bin log from the master and get it over there. But that's how you scale reads in a traditional system, right? In Couchbase, since each node is running memcached, and we leverage that, the hash map in that, since it's RAM-based, is able to sustain extremely high throughput and extremely high rate of connections. I think the demo setup I set up here, is running at about 300,000 requests per second, 200,000, 300,000, something like that. Perry's yesterday in the bigger demo, I think, does 1.5 million. So each of these machines is set up in such a way so that they can service a good amount of reads, meaning that we can always read and write from the active without worrying about contention. Okay? So how does the client find all this stuff? It's very simple. The server has a map on it, and by default, each of our buckets have 1,024 VBuckets within them, okay? And VBuckets are the shards, the partitions, whatever you may think of them as. But those VBuckets will be evenly distributed across however many nodes are in the cluster. So in this case, each node is going to have something like 688 VBuckets, 344 active, 344 replica, okay? Now, each server knows what VBuckets it's responsible for. Each server has a map that lays out exactly where this is in the cluster, okay? And so the clients use this information to essentially hash the key that they're reading or writing to determine what VBucket that key belongs to, and then simply makes the request to that server, okay? When we're adding nodes into the cluster or removing nodes or losing nodes, this VBucket map changes. And the client is actually subscribed to the cluster, and through that subscription, it's able to receive updates to what happens to the VBucket map. And so I'm kind of going to switch between slides and a demo just to show you guys what this kind of looks like in real life a little later. But the VBucket map is what allows us to add nodes in dynamically. It allows us to lose nodes, all while being able to service the data set. Okay? All right. So failover is another concept that you should be aware of. With failover, what we're able to do is if we've got traffic, let's say we're just focusing on the requests that are going to server 3 for right now. Right? In a normal cluster, the requests are going to be evenly distributed across all the nodes. But we're just going to look at server 3. So it's servicing requests right now, and it goes down for whatever reason, right? Maybe it kernel panics. And so what ends up happening is server 3 is responsible for essentially 20% of the data set in this cluster. And so with it down, 20% of your requests are going to fail. Unless you have enabled auto failover, which is going to detect that that node is down, right? And do a promotion. It is going to promote replicas to active, update the topology map, and the clients are going to be able to continue servicing their requests against this cluster against the full data set. Okay? Now, in our case, we can have up to 3 different replicas, right? And so really, each replica gives you the ability to lose another node in the cluster while still being able to service the full data set. Okay? What this means in a distributed environment, right, where I might have a cluster that's spanning Amazon, let's say, West A, B, and C, is that if I've got a bucket with 3 replicas, I can place a max of 3 nodes in any given availability zone. And I always get zone and region mixed up. So if I use the wrong word, just ignore it. So traditionally, that's how we've been able to do some level of tolerance around losing a zone, say West 1A, being able to fail over 3 nodes. Now, replicas themselves are expensive, right? A replica is going to be a full copy of the data set, and any write operation is essentially multiplied, okay? So let's say I have 100 gigs of data, right? 100 gigs of active data. And I'm doing writes at a rate of 20,000 per second, okay? With one replica, I've actually got 200 gigs of data in the cluster, right? And I'm actually doing 40,000 writes at the disk level because each of those writes has to get replicated over to another machine. If I'm talking about 3 replicas, that's 4 full copies of data, right? So 400 gigabytes, 80,000 writes per second that the disk has to be able to handle. So replicas, while they can be used for this kind of thing, they're not cheap, right? Typically, customers that are running high replica count buckets are going to be doing so in environments where it's a read-heavy workload, right? There's not necessarily a ton of writes, or it may be especially crucial data. In 2.5, we introduce a feature called rack zone awareness, okay? And rack zone awareness, while it's designed kind of specifically for racks, it actually gives us a lot of flexibility in terms of how we go about configuring things, okay? Now, what it allows us to do is pick a failure point in the environment now and group things by that failure point, okay? So it could be a hypervisor, it could be a switch, it could be a PDU, it could be different regions in Amazon EC2, okay? But what it allows me to do is have servers in different server groups, and what will happen is the replicas will get organized in such a way so that we can lose an entire group and still have the full data set to work with, okay? So in this example, we have got servers 1 through 3 on rack 1, 4 through 6 on rack 2, 7 through 9 on rack 3. And this is a balanced configuration, okay? What I'm able to do is we're going to organize the replicas in such a way so that, let's see here, the replicas for rack 1 are always going to live on racks 2 and 3, okay? The replicas for rack 2 are always going to live on racks 1 and 3, okay? And so we're going to set it up in such a way so that we can tolerate the loss of one of these groups, okay? So let's take a look at a demo environment, and we'll actually go and set this up too and walk you through something really simple that you need to watch out for. Give me 1 second. All right. So here I've got a cluster. I've called it EC2 West, and I've kind of cheated because the entire demo environment's in EC2 West. But we're going to pretend there's an EC2 West and an EC2 East. And I've got servers in West 1A, 1B, and 1C, okay? So what I'm going to do is I've got a cluster here of 6 nodes, right? And for the server group functionality, what I'm going to do is organize these based on a given group, okay? So here I've got 3 groups already created, right? And let's see here. I'm going to modify these to 1A. 1B. C. Okay, so I've got West A through C right now. And what I'm going to do is I'm going to take each server that's in that given zone and place it in there, okay? And so it's just a drag and drop. I can just do this, and what I've got now is a balanced grouping of server groups. So I've got 2 nodes in each of the different regions. I've got 1 replica configured for this bucket. So even though I've got 1 replica, because I'm using server groups, I'm able to lose more than 1 node and still fail over and still have all my data, okay? I'm going to click Apply Changes, and this is kind of an important thing to note because this has actually bit a couple customers that went live with this feature. The way this works, right, is by placing replicas in such a way so that the replicas for A live on B and C, right? I've organized the groups right now, but I haven't actually moved any VBuckets around, okay? So to do that, what I'm actually going to do is click Rebalance again. And after I've done a rebalance, now this group is going to be safe, okay? From losing an entire group. Now, there's a couple things to be aware of with server groups. One is that no matter how many groups you have, you do need to have a matching number of servers within the group, okay? So here I've got 2 in each, but if I had configured the cluster with, say, 5 in one group, 4 in another group, 3 in another group, that wouldn't work so well, okay? I tested this a while ago. I forgot the results, but they were kind of iffy. So you want to make sure that you want to balance the groups out when you're doing this, okay? Now, here I've got a cluster that's spread across A, B, and C. And I forget the exact ping times, but this is something that we have a couple customers that are doing right now, right? So they've got a given Couchbase cluster that's spread across A, B, and C in EC2. Now, that works because the ping times from the different zones is going to be small enough that it's not going to have an impact, okay? One thing that's important to understand when we span a group over different networks is that because of how we're distributing data, and we'll actually take a look at this cluster right now in detail and see what it's doing, right? If I take a look at this, right, and show it by server, you can see each server is servicing a 1/6 of the workload, okay? So what that really means is that because we've distributed the data set across all the nodes in a given cluster, right, requests against the entire data set are going to go to all nodes in the cluster. And what that really means is if you're going to span a cluster, right, across several networks, you want to make sure that the ping times from network to network are small enough that they're not going to impact either your client application, right, or our own internal replication, okay? The reason for that is, you know, we've got these 3 servers, right? And if I have an app server that's sitting in West 1A, right, 33% of its requests are going to go against 2 of the nodes within the local data center, okay? 66% of the requests are going to go against servers in 1B and 1C, okay? Does that make sense? Okay. All right, so let's see here. So that's server groups. Rack zone awareness. All right. So I took this at home a little bit ago, right? This is from, I think, my application that's running in West and checking ping times for all the different EC2 regions. So you can see here in West, it's 60, 70 milliseconds to reach across. Going from West to East bumps us up to 175 milliseconds. Europe, Asia, those are all 200 plus, sometimes 300 plus, okay? Milliseconds for a ping round trip. So in this case, it doesn't make sense if I want an application to be able to span across, to have availability across a given continent, to span that cluster across both sides, right? It wouldn't make sense for me to have one cluster with some of the nodes in US West and some of the nodes in US East. The reason being, half the requests are going to get hit or nailed with 175 millisecond penalty, from the application server, as well as when we're doing our replications. So the way we really want to set this up is with cross-cluster replication, okay? This is another feature that we've had for some time, and just raise your hands if you guys have played around with it, used it in production. A couple of you? Okay. So cross-cluster replication, it is going to continuously replicate writes that are going on from a destination cluster to from a source cluster to a destination cluster. And so what we have with cross-data center replication is a push-based replication mechanism, okay? And as of 3.0, it's going to leverage DCP, which means that it's going to be much, much faster in terms of actually replicating those changes. We have a lot of different XDCR topologies that are in use in production. Some have multiple chains that are unidirectional, clusters that are living in China that are replicating data back to California. We have clusters that are living in San Francisco and New York that are replicating to each other. And we have one set of clusters that is going to be pretty much ringed. So there's about 50 in the US. 2 in each state are replicating to each other as a backup, and then all are replicating back to a central cloud one. So there's a lot of different ways that you can configure this, right? What it really allows us to do is have a lot of tolerance in terms of if a data center goes out or an entire region goes out or an entire zone goes out, we can still continue servicing requests from an application itself. Let's see here. The replication itself is going to be cluster aware. And so it is going to use the same concept as the clients do, the VBucket Map, to actually go about and figure out the topology of the cluster, what nodes are in it, and when nodes have added or removed or changed. So once you set up XDCR, it's able to know where it should replicate to continuously without you having to do anything administrative-wise, okay? The administration for it is also really simple. We're going to show it to you in just a second. You can do it through command line, you can do it through REST, or you can do it through the web GUI, okay? All right, so this is kind of showing the flow of operations when we actually hit a node with a write. What we're actually going to see is the node's document is going to go into the memcached managed cache, right? And at the same time, it's going to go on multiple queues. In 3.0, it's a DCP queue, which allows us to replicate straight from RAM to RAM on the destination cluster, okay? And what that means is the throughput for XDCR replication is actually much, much higher now in terms of what it's able to actually do. We used to, if you're using a 251 cluster, we'd wait till it had hit disk before actually sending it over. So XDCR replication was a little bit slower then, and there were some issues with consistency if you're reading from both data centers that are actually getting replicated. Okay. So let's go and just set this up real fast and show you what it looks like. So here we've got our EC2 West cluster, 6 nodes, right? We've got one data bucket that is doing around 197,000 ops per second, okay? And it is doing 132,000 reads and about 70,000 writes against 100,000 items, okay? So what we're gonna do is we have a cluster in East, And what we're going to do is we're going to set up a single unidirectional replication, okay? And in this cluster, I've also got 6 nodes. I haven't bothered to sort them out into server groups. I've got a default bucket, and we're actually going to create a second bucket after I resize this guy. Give me 1 second. And good. Okay, so I've got a second bucket created. It's 6 nodes. It actually doesn't need to be 6 nodes. It can be, you can actually replicate from different size clusters to different size clusters, okay? So you might have a production cluster that's taking a lot of load. It is going to be running with 20 nodes in the cluster. You can have that actually replicating to, you know, like, let's say a 3-node cluster if you didn't have any performance needs on that destination cluster. So the way that we go about setting this up is that first we go to XDCR. We're going to define a remote cluster, okay? And the cluster reference, we're going to give it a name, EC2 East. And we just need one IP address from one of the nodes in the remote cluster and the password, and that will allow us to connect to it. Now, when we connect to the remote cluster, what it's actually going to do is something interesting, and I thought I'd show it to you just since most people don't see this kind of stuff. Default buckets, streaming, bucket 2. So this is kind of what goes on behind the scenes when a client connects or when we're connecting to a remote cluster through XDCR. What we get is this VBucket map that so many people have been talking about. Actually, I don't know if anyone's been talking about it aside from me. But this is what we get, a VBucket map. And this is a rather large piece of JSON that lays out the location of every single VBucket in the cluster. Now, if we throw this into a JSON viewer, we can see how it's organized, okay? And kind of what happens behind the scenes, how different things figure out where different things are, okay? You guys see this okay? All right. So there's a lot of different stats here, but the ones that we're going to focus on are the VBucket Server Map. Okay? So we can see we've got 1 replica in this cluster, and we've got 6 hosts, okay? Each host is enumerated out with both its IP as well as the port that it's listening on. And we've got array notation for this. So 6 servers, we've got server IDs from 0 through 5. So in this VBucket map, right, the way I read this is the active VBucket lives on server 0, the replica lives on server 1, okay? If I go to another VBucket, right, we can see the active is again on server 0, but the replica is now on server 3. So it's like this for all 1,024 VBuckets, but this is what we're using underneath the hood when we connect to a remote cluster through XDCR, and we're trying to figure out where the VBucket's located at, how many nodes are in this cluster, where do I actually need to send my data to, okay? So when I've created that cluster reference, right, that's the start of this process. Now I'm actually going to go and create an actual replication, and what I'm going to do is select the bucket I want to replicate from to the remote cluster and the bucket that I want to replicate to, okay? And once I click replicate, we're actually going to start seeing items show up in this remote cluster. So you can see here bucket 2 is pretty much already caught up on item count. It was able to replicate all that data over extremely quickly. And cluster number 1, right, EC2 West, it's still got write load going to it. It's still got 60,000 writes per second going to it. And so what we're actually going to see in cluster 2 is we are going to see pretty much the same amount of operations going on, but these are all coming in through XDCR. So you can see here that this cluster is handling 70,000 operations per second through XDCR replication. The way you can actually get information about this, right, you can look at a couple things, right? You can look at the incoming XDCR operations for stats, and this shows things like how many metadata checks we're getting or we're doing, right? The total ops per second. Since we're using 3.0, I can actually look at the DCP queues and I can see exactly what's going on with TCP replication, right? We can see some really interesting stats, mainly how many items are in queue, how fast we're draining replications on a per second basis. And so in 2.5, since this was disk-based, the queues would grow to much, much larger. Since we're using RAM to RAM now in 3.0, the amount of items that are sitting in the queue at any given point in time is like 100, right? So that's not too bad if we're considering the fact that we're doing 70,000 writes per second across the cluster itself. So let's see here. Let's go back to this. So like I was saying, there's a couple different ways that we can do replication configurations. So the unidirectional, which we just set up, is represented here. And this is probably the most prevalent way that customers will deploy XDCR replication. You can use this, a lot of people are using it for backups of some kind, right? XDCR gives you a way to have a continuous backup of your production data. We have some people that used to take manual backups from production on a weekly or monthly basis so that they'd have real data to test on in QA or test dev, right? But now they can actually replicate this from production into a tester QA cluster and remove some of that overhead from the additional work that they used to do manually, right? So we also use this in a lot of cases for integrations. So connections to Solar and Elasticsearch. Elasticsearch is pretty interesting. It's a technology that's kind of similar to ours, but focused in a different area. But there's a plugin for Elasticsearch that essentially allows us to fake out Couchbase and have Elasticsearch pretend it's a cluster. So we're able to replicate all the data that's coming in into a completely different technology using this.
So in this replication side, is this database available for query? Can we?
Yes.
Okay, read only?
Yeah, I mean, so you can do reads against, let's say, cluster 2, right, without any issue. I'll talk about writes in just a second, okay? Okay, so a bidirectional replication is really simple. There is no setting in Couchbase to do bidirectional. You're simply setting up a unidirectional connection from cluster 1 to cluster 2 and going the other way, right? So it's a push-based configuration. And so on EC2 West, I'm going to set it up to replicate to EC2 East. On EC2 East, I'm going to set it up to replicate to EC2 West. And that gives me a master-master configuration, okay? There's a lot of reasons why you would want this kind of thing. The ability to do DR probably is the main one, right? To be able to continue on with your application if a data center is to go down for whatever reason, right? Data center locality, the ping times that you just saw, instead of having to do a 200 millisecond round trip to the East Coast, right? I can go do a 70 millisecond ping time to the West Coast data center and have my data faster and closer, right? There are things to be aware of, right, when you're doing a master-master setup. And mainly they come around write conflicts, okay? So in our technology, we use a number of different aspects about the data to actually determine that there's been a write conflict. We use about 5 different pieces of metadata, essentially the CAS ID, the expiration, the flags, the revision ID, and 1 or 2 other things. And ultimately what it comes down to is that with our conflict resolution in the current form, it is a most update wins type of scenario, okay? So it's not a last update wins. So let's say I'm doing a replication master-master across these 2. I'm writing the same item in both data centers, okay? Let's say the network is slow. I do 20 writes against the item in the East cluster, right? Those are slowly making their way over. And then I do 1 replication, or 1 write to the West Coast data center. And I do that at a later time. But since replication is slow right now for whatever reason, let's say we've got a network blip, it takes a while for those replications to actually get over, okay? So let's say it takes a couple minutes, okay? The write to replicate to the data center in the West was the last write, but its revision ID is going to be substantially lower than the cluster in the East that had 20 writes against the same item. And so when my network is back up and running and I'm able to replicate, what will happen is there'll be a write conflict, and essentially the last write from the east cluster is actually going to win and propagate amongst the clusters, okay? So even though there was a last write in west, which time-wise was the last write and what was the correct write, right, that one's gonna get lost. So you do need to be extremely careful when you're doing master-master replication with Couchbase, because there are scenarios where you can lose an update because of the conflict resolution, and that can happen. So typically what we tell people to do is if you're doing master-master within 2 clusters or multiple clusters, you should have some concept at the application level of stickiness to a data center, right? And so let's say I'm writing customer records, right? If I'm writing a customer record for myself, you know, I might use something to determine before it even hits that data center that I'm on the East Coast and use that in some way, shape, or form so that when I do writes for my document, right, it's going to the West data center, okay? And the reason why I want to do that is, again, I can technically write to both data centers, right, for my same item. I just may lose an update if it happens at a quick enough pace, right? So revision ID is what it's based off of for the most part. Most updates is really what it's based off of. I wasn't able to set up my other machine, but I was going to show you what the revision ID looks like. You can actually see it if you do a CouchDB dump on one of the VBucket files on your Couchbase system. You can see all the metadata for a given item. And it's something I played around with, but it's something that you, again, need to be careful of when you're doing master-master, okay? All right, so if we put it all together, we've combined server groups and we've combined cross-cluster replication in this diagram. And what we have is a cluster in the west that is spanning all 3 regions, zones. Which one's A, B, and C? Zones? Okay, so spanning all 3 zones, and then we've got a cross-cluster replication spanning the 2 regions, okay? So in this way, I can actually lose an entire region or zone. Let's say I lose 1B, right? I'm able to do failovers against the 4 nodes that are in that cluster and still be able to service the full data set, still be able to do writes against the data, right? If I lose the entire cluster, let's say EC2 East, from an application point of view, I've still got the West data center up and running, and it's still got a replicated copy of the data itself, okay? So this is kind of what it ultimately looks like in terms of using these 2 technologies within Couchbase to give you a very highly available application. I don't think I have anything else, so if you guys have any questions, just let me know. Go ahead.
In the last slide, when you're saying one rack, let's suppose all the 4 servers are gone, right?
Uh-huh.
The data will be available on the rack 2 and rack 3.
Correct.
Right? And once you hit the rebalance button, then it will rebalance, right?
Yeah, there's a couple ways. So you would do, for whichever rack went down, you would fail over all those nodes, okay? You would essentially be left with all the active data in 2 remaining racks and probably very little replica data. So you could either rebalance right there, and that would regenerate the missing replica data, or you could wait for, you know, one of those racks to come back online, add them back in, and then rebalance so that you have your full capacity again.
Right.
Okay.
So let's suppose I choose the option of rebalancing.
Mm-hmm.
What will happen on the XDCR side on EC2 East?
Mm-hmm.
Rack group 1 will be all blank out over there also, and only group 2, group 3, or?
No, so when you fail over, right, when we're doing XDCR, we're replicating active VBuckets. So when I fail over, I promote those replicas that were in the other 2 racks to active. And so I've got the full 1024 again. And so for XDCR's purposes, right, it's aware of what happened. It's aware because it was subscribed to that VBucket map itself. So it knows that replica VBuckets got promoted to active, and this is where it should go now for all these different VBuckets. So it's able to continue seamlessly even though we've lost nodes or changed the topology of the cluster. And the same applies if I add or remove nodes, right? That's kind of why I showed you that VBucket map. That's the thing that tells us exactly where to go for a given piece of data. Okay?
So I know if a single node goes down or a group goes down, the client becomes aware of that, and you know we get the replicas being promoted and so on.
Uh-huh.
So that's sort of, the client is all aware of those things
Yep.
Is the client, can the client be made aware of the cluster? So if your whole active cluster goes down, the client will then send any request to your other whole cluster.
Yeah, so the question was that the client is aware of a single cluster, but is there a way for it to be aware of multiple clusters? And so the answer is yes, but the client doesn't do anything, technically that's like this, right? When you create a connection to Couchbase, you're creating a connection object, you're instantiating that object with the IP of a cluster, the credentials, the specific bucket that you want to connect to. And so that's all you're doing. So people that have this set up for multiple clusters will simply create multiple connection objects, right? And so if it's the case that they get a request and it times out, then they may set up their app to just simply reuse a different connection object to a different cluster.
That's what I think.
Yeah, but there's nothing automatically for the client so that it will dynamically do this. It is something you have to do at the code level. Okay?
So if we are doing a one-way cluster or one-way replication, so if I have a main server, would there be any hit in this performance hit in this application?
So is the question, is there a performance hit for turning on XDCR?
Yes.
Okay. That's a good question. So performance-wise, you have to understand kind of what's going on when we create that XDCR replication. We're doing a couple things, right? We're reaching out to the remote cluster. We're getting a topology map. We're instantiating multiple connections from each node of cluster 1 to each node of cluster 2. And as well, we have to reach out to that cluster to replicate items to it. But it's not quite that simple. First, we have to check to actually see if we're needing to replicate, right? Does this destination cluster need this replication event? And so we reach across to do what we call metadata checks. And so there's a lot of network overhead involved, and the resource is going to come in play in a couple different areas. The resident memory for Erlang is probably going to go up by a gig or 2 gigs resident. CPU utilization is probably going to go up because there's additional processing that's needed to kind of cycle through the VBuckets, make sure they're replicated, as well as doing remote metadata checks, okay? Network-wise, network throughput is really where you're going to see the main hit for turning replication on, right? We've got to do that initial first-time replication to get the entire data set over. And then whatever your write workload is, that is going to get multiplied again, okay? So there is a bit of an impact, and it makes sense that there's an impact because it doesn't come for free. But there will be some. So around memory, CPU utilization, and network throughput.
So another question. So if we have a requirement of auditing any lines which are in order to do this thing, is it possible to do just the delta replication? That every time anything is changed, update on the other one, but only look over people look over it?
Yeah, not right now. We don't do any in-place updates. So for any kind of operation that you do, let's say I've got a document, a JSON document, and it's a very large one, and I just update the name in it, right? So I've modified one attribute within like a document with 100 attributes. We're going to replicate that entire document, right? We're going to write that entire document down to disk. So no, there's not really a way to save revisions. Technically, revisions are saved, right, at the disk level because we're using an append-only format to store everything on disk. So technically, it is available for a while, but once we compact that data, then it's gone. Okay? Go ahead.
I had a question related to views across data set. Right now, there is no support in 2.5 to configure the views across data set.
Uh-huh.
Can we expect this in later?
No, it's still something that you have to manually do. So the question was, do views get replicated across with XDCR, and they don't. You had a question?
Yeah, two questions. Everything you described here, is it for 3.0 only, or is it available in 2.5.1?
Yeah, good question. So for those of you that didn't hear it, for everything described above, is it applicable only to 3.0, or does it apply to 2.5 as well? And so everything that we've talked about, server groups and XDCR, right, they're available in both. I think in 2.5 we added rack zone awareness or the server groups. So if you're using a 2.2 or 2.0, you won't have that functionality. XDCR has been in the product since 2.0, but it's changed numerous times, right? Performance-wise, you will get the best performance out of the 3.0 version of XDCR simply because we're no longer using the disk, right? So there's less disk I/O overhead for reading that data in additional time to send it and replicate it over to the remote data center.
Okay, my next question is the bidirectional. How do you guarantee, is there, I guess, is it programmatically, I can check the master on the replicated side is already written?
Okay. So the question is, how do I check programmatically that the remote data center got that right? There is nothing really native right now in Couchbase that will do that. There's the underpinnings of things that will allow for that kind of thing in future versions. Right now, one thing that you could do is you can actually have another connection object created to the remote data center and do a get with meta. And so get with meta gets you essentially the metadata of the item itself. And so you can compare programmatically the CAS values or the revision ID or any number of other things within the metadata that make an item unique. But you can use that to make a determination for if it's replicated over. That's kind of the hacky workaround for how to go about doing it. But right now, the SDKs don't have anything specific to doing an observe across data centers, if you
So
will.
when I do writes, there is no return error, return message that I need to wait.
Yeah, your client knows that, I mean, there's durability options within a cluster, right? You can observe writes across replicas, you can observe writes across disk, but that's one specific cluster. So there's nothing spanning the data center, right? The client doesn't really know that there's an XDCR replication to begin with. Okay? Anyone else?
When you talk about the conflict resolution, what happens when there is the same number of updates of both?
Okay, so the question is, with conflict resolution, what happens if there are the same number of updates on both sides? Okay, so revision ID is the thing that we were talking about that kind of shows at a rough level the number of updates. But the revision ID is actually one part of the metadata that we're going to use. We're actually going to use 5 pieces in total to create one number. So we use the revision ID, we use the flags, we use the expiry, we use the CAS, and one other thing, I think. Where's that 5 already? But we use all those things to create one ID to check. Revision ID is just the most obvious. So if the revision IDs are exactly the same, we simply go down that chain, right? We look at flags, we look at expiry, we look at CAS, and we look for a higher one on one of those. And so if there's a conflict resolution detected, the rev IDs are the same, we're going to look at other pieces of metadata to resolve that conflict. Anyone else?
I'm wondering whether it's configurable or customizable of the conflict resolution algorithm.
Yeah, right now it's not, but I think we've got enough requests for it that the PM team is seriously considering it on the roadmap. But right now there's nothing concrete. And I think we're out of time, so thanks everyone for your time, and hope you have a good conference.